Let's talk polynomial operations. In these notes, we're going to add, subtract, and multiply polynomials. So first, to talk about what we're actually doing here, we are simplifying these expressions. We are not solving any equations. So to simplify an expression is to rewrite the expression without parentheses or negative exponents. I'm not sure if we'll have any negative exponents in these notes, but just in case. So you want to get things in simplest terms. So first, let's look at polynomial addition. This is essentially just combining like terms. Add the coefficients of terms that have the same variables with the same exponents. We want to make sure our answers end up in standard form as well. So really just look at each polynomial and add up the ones with the same variables and exponents, starting with the highest degree terms. So in example 1a here, we'll do 4x squared plus 2x squared gives us 6x squared. And then we have negative 5x plus 3x is going to give us negative 2x. And then 6 plus negative 1 is 5. So after we add these polynomials together, there is our answer. And again, notice we're not solving anything. This isn't an equation. We're just simplifying the polynomial. All right, example 1b, do the same thing. Now here we have an x cubed, but there's no x cubed in the second polynomial. So we're just going to leave that 2x cubed alone. Nothing is going to happen to it. But we do want it to come first because of standard form. A very similar thing happens here with this 5x squared. There's no other x squared term to add to it, so we'll leave it alone as well. Taking care of these two. So next we'll do 1x plus 3x. That gives us 4x. And then 7 plus 1 is 8. So there's our simplified polynomial there in standard form. Now subtraction works very similarly to addition, except we are subtracting. Now you could subtract each term, but I find it much easier to distribute the negative sign into the second polynomial, and then we can just use addition. And again, we want to write our answers in standard form. So we'll use the distributive property. Think of this as a negative 1 here that we're distributing, multiplying into each of these things. So we'll have a negative 2x squared, a negative 3x, and a positive 1. And then we can just use polynomial addition. Right, so 4x squared plus negative 2x squared is 2x squared. Negative 5x plus negative 3x is negative 8x. And 6 plus 1 is 7. And again, we could have subtracted, but then it's slightly more complicated, right? We would have done 4 minus 2, that's pretty easy. Negative 5 minus 3, 6 minus negative 1. This is all the same as what we did. It's just a little more straightforward if we change it to addition. All right, example 2b, same thing. We'll change this to addition and just distribute those negatives throughout the polynomial. Okay, so 6x cubed plus, there are no other x cubed terms, so we'll leave that 6x cubed alone. And then we still have that negative. And this is why it might be important to think about changing it to addition, because we have this negative 4x squared that there's nothing else, there's no other 4x squared terms. And so if we didn't change it to a negative, we might accidentally leave it as a positive. But since it is negative, we'll have minus 4x squared. And then negative 7 plus negative 9 gives us negative 16x, and 8 plus 5 is 13. All right, so addition and subtraction, pretty much the same thing, especially if you consider distributing the negative sign throughout the second polynomial and then using addition to get your final answer. Multiplication, we are going to multiply here in these notes just by at first by a monomial, and then we'll do a couple binomials, and it looks like we're going to do some more complicated ones as well. So one thing you want to keep in mind is we are using the distributive property to multiply each term in the first polynomial by each term in the second. And then combine like terms if necessary, write your answers in standard form. So again, like I said, we'll start out with some monomials times a polynomial, so this 2 just gets distributed through for 2x minus 2. Pretty simple. Next, we'll distribute this 3x. So we get 3x squared, right? X times x is x squared, plus 9x. Now, if you have more than one term, we'll have to make sure that each term in the first polynomial gets multiplied by each term in the second. So x times x is x squared. X times 4 is 4x. 1 times x is x. And 1 times 4 is 4. And then we can combine like terms right here. So x squared plus 5x plus 4 is the final answer here. Moving along to example D, we again have two binomials here. So 3x times 2x gives us 6x squared. 3x times negative y, make sure that negative sign stays with it, it's going to give us negative 3xy. 4y times 2x is going to be 8xy, right? Just list your variables there. If they're different bases, we can't combine their exponents. And then 4y times negative y is negative 4y squared. Then we can combine those middle two terms. 6x squared plus 5xy minus 4y squared. Now in this case, these terms all have the same degree. They all have a degree of 2. Right? We have x squared, xy, and y squared. Those all have a degree of 2. So essentially, to arrange them in standard form, they have the same degree. So it's like, how do you choose? You want to just put them in alphabetical order is the way I would suggest doing that. Here's all x's. Here's a mix of x's and y's, and here's all y's. So this is as orderly as we can get that. All right, we're combining skills here for example E. So first we'll distribute these. Make sure that negative stays with the m squared. So 15, not x, m squared minus 12m. And then we'll do the second set, negative m to the third and negative 3m squared. So what's nice about this distributive property deal here is that at first it was set up as this polynomial minus this polynomial. But since we included that negative sign in our distribution, now we can just combine like terms instead. So our answer will start with a negative m to the third in standard form. Then we can combine 15m squared and negative 3m squared. That's 12m squared. And then we just have minus 12m left. Last one here, we have this 4-term polynomial multiplied by this one monomial term. So we'll just distribute that all the way through and get our final answer. So here we have 8x to the 5th minus 20x to the 4th plus 32x to the 3rd minus 4x squared. And then just double check and make sure that we have nothing to combine and our answer is in standard form, which it is. So we're good there. So there's a quick crash course on some polynomial operations, addition, subtraction, and multiplication.